Hello, submarine surfers. We're going to go over and have a nice lesson about ocean topography, the ocean floor. What does it look like? We're going to start out with looking at our fantastic map. This is our topographical map. It's three-dimensional because you can look at it and you can see it has raised spots, the islands, undersea parts, the landscape. We go up to see the mountains and the valleys. And so this is a great map for looking at. It's different because it's not showing us the countries as much as it is what the Earth's surface looks like. So when we look at this map, remember, if you look along the edges here of the coast, you'll see it's whitish, and then it goes to a little bit lighter blue, a real light blue, and then it gets to be a true blue, and in spots it gets to be dark blue. In some places it's darker, and in some places it gets even darker. Like for example, along the edge of Puerto Rico here, there's a very dark area. So when you're looking at the ocean, the darker the blue, the deeper the water. The lighter the color, the white would be the very edge of the continents themselves. So we're going to go on over to another slide here, and we're going to look at some underwater features, and then we'll come back to this map maybe later and try to find those same features here. Okay? Okay, this is our ocean floor feature map. The different letters on this map represent the different features that we would find under the ocean. Okay, so we're going to start out. Up here we have the continent. This is the land. This is where we would live. Now this shows rocky, rocky shoreline, and here in Georgia we have a very flat, sandy shoreline, but different places. But at any rate, this is the continent. The first part of the ocean, as you first start walking out into the water, the shallow part, this is going to be the Continental Shelf. The Continental Shelf, like if we're down at the beach at Tybee Island or Hilton Head or in Florida someplace, as you walk out into the water on the sandy ocean floor there, that would be the Continental Shelf. Now, the farther you go out, it starts getting deeper, but this is the part it's technically part of the continent. All right. So, as we go further out, then we come to the Continental Slope. The slope. When you think of a slope, think of a ski slope. Here's somebody out skiing and they're going down the slope. So the Continental Slope connects the Continental Shelf to the actual bottom of the ocean. Okay. Briefly, if we look over here on this side of the map, there's our Continental Slope, and it comes down to the flat ocean floor, which we'll talk about in a second. On this side, this is really more like the coast of California because it drops off pretty deep and it goes into a really deep part of the ocean, more into a trenchy type area, whereas the east coast comes down gradually and goes into more of a flatter part of the ocean. All right, so once we go down let's come back over this side. Once we come down to the ocean floor, we get to what we call an abyssal plain. So this area in here would be the abyssal plain. The abyssal plain is the actual bottom of the ocean for the most part. It is the deepest part of the ocean anywhere. The flattest part of the ocean, excuse me. Not necessarily the deepest, but it's the flattest place on Earth. And the reason it's so flat is because for millions and millions of years, we've had sediment and dead creatures and things and all drifting down to the bottom of the ocean floor here. And this could be covered in a layer of sediment, a half-mile thick in some places. Dead little critters and bones and dust and dirt and all. And that's what makes this area so flat. So we've got a continental shelf, which sticks out from the wall, kind of like a shelf in your room. We go down the continental slope, and that slope brings us to an abyssal plain. All right. Next, we may encounter along the continental slope, there may be an opening, a deep canyon or a crevasse. This could be a submarine canyon. All right. Letter C is actually pointing to something called a submarine canyon. Now that submarine canyon might be caused where a river had been dumping into the ocean and it carved a channel down through this continental slope. Could have been an earthquake, a landslide of some sort. But at any rate, somewhere within the continental slope, there might sometimes be a submarine canyon. All right. Now, another important feature of the ocean floor would be this area right in here, right in here. This would be the mid-ocean ridge. The mountains piled up on either side would be the actual mid-ocean ridge, and then the crack down the center is called the Rift Valley. The Rift Valley. So what's actually happening here is magma and stuff inside the earth is pushing upward, and it's pulling the earth apart. And it actually splits it open. The Rift Valley, when you think of see the word rift, it's spelled R-I-F-T, but I like to think of it as R-I-P-P-E-D, like it's been ripped apart, because this part of the ocean floor is going in this direction, and this part's going in this direction. So this is a Rift Valley. Now once it rips open, we have magma, lava oozing up from the ocean floor, and it hits that cold water, and it makes it harden very quickly, and it piles up and causes a ridge. We call it the mid-ocean ridge. Now, the mid-ocean ridge is really the world's longest chain of mountains, because this chain of mountains here, and this can be pretty tall. This chain of mountains is actually about over 40,000 miles long, and it stretches around the world, kind of like the seam around a baseball. So the mid-ocean ridge, this is the mid-ocean ridge, and down the middle of the mid-ocean ridge is the Rift Valley. Now, we also have underwater mountains, and this is a seamount. This is a seamount. Now, these seamounts can be active. They're usually volcanoes. They may be active volcanoes, or they may be extinct, dead volcanoes. They may never erupt again, but they're on the ocean floor. Sometimes these seamounts can get very, very tall. They erupt and erupt and erupt until finally they reach up above the water, and the part of a seamount that sticks up above the water is called an island. An island. So, for example, Hawaii, the island of Hawaii, it's a giant, giant seamount, and on top of it is this huge island of Hawaii. In fact, the island of Hawaii is the world's tallest mountain. If you measure from the bottom of the ocean to the top of the tallest mountain, Mauna Kea, on the Big Island, that would be the world's tallest mountain. Now, sometimes out in the ocean, these seamounts, because of wave action, because of ancient activity, the tops of them could have been worn away. So if you look at letter F here, this thing, you can see it's got a flat top, and it's right even with the top of the water, with the level of the ocean. This would be a guyot, a G-U-Y-O-T, a geo or a guyot. I'm not sure the way to say it. I've heard it both ways. But a geo is a seamount or a volcano that's had the top flattened out and smoothed off by ocean waves. So let's recap. One more feature I almost forgot. This is a deep sea trench. A deep sea trench. Now, a deep sea trench is where part of the ocean floor is pushing down underneath another piece of crust. In this case, it's continental crust, part of the continent. The ocean floor is actually being pushed down, and as it goes down, it leaves a deep, deep canyon in the ocean floor. We call it a deep sea trench. A deep sea trench is actually the deepest part of the ocean anywhere. In fact, the deepest hole on Earth is the Marianas Trench, and the Marianas Trench is over 36,000 feet deep, and it's the deepest place on the planet. All right, so we got Continental Shelf, Continental Slope, we have Submarine Canyon, we have Deep Sea Trench, we have Abyssal Plains over here and over here, flattest places on Earth. Again, we have a Continental Slope over here. We have a seamount, which is an underwater volcano, and there are literally thousands upon thousands of undersea volcanoes. Sometimes that undersea volcano can erupt and erupt and erupt until it gets so tall that it sticks up above the surface of the ocean. Sometimes those seamounts can be close to the surface of the ocean, and the wave action can flatten them off. Down the center of the oceans in different places, we have mid-ocean ridges. Mid-ocean ridge is formed by a rift valley which splits the ocean floor open. Magma oozes up and piles up and forms this giant mountain chain. And the world's longest chain of mountains is formed by the Rift Valley. Okay? Okay, this is our model, the model I showed you in class. And just going to hit the ocean floor features again from a little bit different perspective. So bear with me. Here we got the beach, got a nice lovely palm tree up here. And then so the water's shallow. This is our water level across here. Here we got our, what was this called? The Continental Shelf. Continental Shelf. And we slide down the the Continental Slope. Continental Shelf, which sticks out. This is actually part of the continent. Continental Slope, and it goes down to the Abyssal Plain, flattest part of the ocean anywhere, flattest place on Earth. Down here, I've kind of colored this in a little bit to show us we had a Submarine Canyon. Submarine Canyon, which is part of the Continental Slope. Come on out here, and even though it's not very tall, this is supposed to represent our mid-ocean ridge. Our mid-ocean ridge, and here in the middle, and this what's really good about this model is it shows the magma and the lava coming up and splitting open the ocean floor and filling it up. Okay, it comes up and fills it up through the middle there, and pushes this aside and pushes this that way and piles up there and piles up there, and that helps make out the mid-ocean ridge. Continuing with our model. Over here find that we got some seamounts, okay? Now in this case, seamounts might be active volcanoes or they may be dormant, extinct volcanoes, but these were all formed by underwater lava eruptions. As you can see, it comes up, and here's a good active volcano. This one not so much, this one not so much. And then on over here, again, we see our deep sea trench. And notice how very, very deep this is. And again, we're looking at where the ocean plate, our mid-ocean ridge, is back over this way. And the mid-ocean ridge is pushing this piece of crust over this way. And as it runs into this piece of crust, this piece is running over the top and pushing that one down in. So as that goes down into the earth, it kind of pulls this down and makes a deep sea trench. And then this is being melted. This piece of ocean crust is melting, building up lava, which makes pressure, and over here we have more seamounts being formed. This is another exciting map. I really like this map. This is what we call an ocean floor map. And the thing I wanted to really show you about this ocean floor map is the mid-ocean ridge. I told you how long it was, how incredibly long that mid-ocean ridge was. Look at this, just like the seam of a baseball, it comes way around, goes on around like that, comes up here. It's connected in bits and pieces here, comes way down here. But if you look real close, right down the middle, you might see there's the Rift Valley. See this little dotted line area? That would be the Rift Valley, where it actually splits open, and the mid-ocean ridge is what drives the continents apart. Because, and something we'll learn later on, if you look at the shape of South America and you look at the shape of Africa, it looks like they used to fit together. And then if you'll notice the shape of the mid-ocean ridge, it fits right along there. So this piece is pushing this direction, and this side's pushing that direction, and it's splitting it apart. As we come on up further, we'll find Iceland is part of the mid-ocean ridge, and it's right up in here. I don't think it shows on this map very well. But to continue, if we look here along the coast of Africa, you see how that looks very deep? Well, they don't have much of a continental shelf there. Very, very narrow continental shelf. The ocean drops off pretty deep there pretty quickly. On the other hand, the southern tip of South America down here, look how wide that is. They got a huge, really, really huge continental shelf sticking out here. And then it gradually drops down to the Abyssal Plain. Continental Slope down into the Abyssal Plain. The west coast of South America is incredibly deep. This is the Himalayan mountains. Here's where we've got the ocean crust pushing up underneath the continental crust and makes a really, really deep part of the ocean right here. And also the coast of California, also it drops off pretty deeply there. But again, remember, the mid-ocean ridge is the longest chain of mountains on Earth. Okay, back to the world's greatest wall map. So we're going to summarize our lesson by looking at these different parts of the map here and try to find some of the features. We're going to start out down here at the tip of South America because it's got such a nice continental shelf sticking out here. And then we can see the colors very clearly graduated. So we've got a continental shelf, and then we can see this area here where it slowly gets darker and darker. That would be our continental slope, dropping down into a nice large abyssal plain here. Okay, a nice large abyssal plain. And if you look at this map, there are quite a few areas where we got some huge areas of abyssal plain. Okay, abyssal plain areas here and here and here and around here. And now these abyssal plains can be parallel right along the mid-ocean ridge. Remember we said the mid-ocean ridge, here's Iceland. Iceland is part of the mid-ocean ridge, and that mid-ocean ridge comes down, runs down the middle between North America and South America, comes around the tip of Africa, on around this way, and then it's a little bit more difficult to tell, but it actually comes on up like this. But now remember, the mid-ocean ridge is where the ocean is being split apart. You've got a tall chain of mountains on either side. There's mountains here and mountains here. And right down the middle, almost like this little red piece of a red line here, that would be the Rift Valley, which is pushing it apart. We'll look on over, and various places, we can see these bumps sticking up. Those would be seamounts. Remember we said seamounts are formed by underwater volcanoes. They may be active, they may be dormant. Some of these seamounts may be tall enough that they reach to the surface of the ocean, but they've been shaved off and flattened by the action of waves. And so instead of calling them seamounts, we would now call them geos or guyats. Then over here on the edge of our map, we can see there's Hawaii, the big island of Hawaii. The big island of Hawaii, if you'll notice, it's got colors on the top of it, and actually goes to kind of a reddish orange. And if we look over here, we know these are the Rocky Mountains, the Andes Mountains, and the Himalaya Mountains. Well, we know these are mountains, and if we notice the colors very dark orange, meaning the taller mountains are darker colors, and if we notice the very tip top of Hawaii, it's a pretty tall mountain. And in fact, if we start down here on this abyssal plain and measure to the top of Mauna Kea, which is the tallest mountain in Hawaii, we have the world's tallest mountain. Of course, if we measure from the land to the top, then Mount Everest is the tallest mountain. And speaking of Mount Everest, if we went over here, and it's just off the edge of this map, to the Marianas Trench, the Marianas Trench is so very deep that if we took Mount Everest and put it into the Marianas Trench, it would be the top of that mountain would be 1 mile underwater. Think about that, a hole in the earth so deep that if you took the world's tallest mountain and put it in there, the top of that mountain would still be 1 mile underwater. So we've got some really, really special places underwater that we can't even begin to see. And it's only in recent years that we've learned so much about this. And the way we learned about all these different features underwater is through echolocation, using sound waves, and the official name of that is sonar. The Navy has sonar that mapped out the bottom of the ocean floor using sound waves, and like I said, that's called sonar. All right, so try to remember all these things we've talked about, and you may want to watch this video more than once, okay?